Hello and welcome back to Math 100. Today we are going to cover section 2.3. The first two sections of chapter 2 were about percentages. And although percentages do continue to play some role, we now move on to different types of word problems. Okay, the term word problems, okay, that's not most people's favorite. Okay, in fact, it's not one of my favorite either. But life is filled with word problems, okay? And so we are going to deal with or address specific types of problems in this section, mainly rates, proportions, and those that involve some large numbers. So let's get started in section 2.3 on ratios and proportions. Let me share my screen and we will get started. All right, the topic or topics of section 2.3 are ratios, but more specifically rates and proportions. All right, so some of the very practical questions that we face each day have to do with rates and proportions. All right, so the first thing is whenever you see these word problems, use your mental faculty to try guessing or estimating the answers first. Okay, now you may not know the exact answer, but that's okay. Try to see what a reasonable answer may look like. That is a general guideline for this section. Right now, when we talk about rates and proportions, again, you may want to read the book because in this section, section 2.5, the textbook defines what we mean by rates, ratios, and proportions. But basically, a proportion is an equality of two fractions, right? So now before I go on further here, for extra support, okay, remember we had a non-credit course specifically designed to address difficulties and challenges on percentages. For this section, sign up for non-credit math 005. 005 is called rates and proportions. And so that a specific module-based non-credit course, which is completely free to sign up, and it's very low stakes. That is for you and for your extra support for this section 2.3, basically for chapter 2. I think it'll be quite appropriate if you find that this section is particularly difficult for you. Okay. All right. Now, when are two proportions equal? When are two proportions equal? I'm going to use my writing and let's see if I can change to my pen or writing mode. Okay, so we call fractions a over b and c over d equal to each other. And this is, by the way, the way a proportion can be set up, right? So when you say two proportions, A and B and C and D, they are equal to each other when, if and only if AD is equal to BC, okay? This is known as cross multiplication for an obvious reason. AD is A times D, has to be equal to B times C. Okay, and in fact, this is the definition of what we call equal fractions. Two fractions are equal. Two fractions, A over B and C over D, are equal to each other if and only if AD is equal to BC. And so, anytime you set up a equation of two fractions, we call that proportions, then you can always use cross multiplication to get your answer. Now, there may be other ways to make more sense, okay, when we answer these questions, but and I will try to show you a couple of ways to solve each of these problems. But the main way to do these questions is to set up a proportion. Okay, number one, if driving, let's say you're driving 400 miles, okay, and if that takes 12 gallons of fuel, how much fuel is needed to drive 950 miles? Okay, so 400 miles, you need 12 gallons. 950 miles, how many gallons? Now, before we set up the equations, let's try to estimate or guess what the answer should be. would the answer be like 2 gallons? No, of course not, all right, because you're driving more than twice as much, right? So it'll be a little more than 2 times the number of gallons you need. So twice 12 is 24. So you know you need at least 24 gallons and probably more like 26 or 27 gallons. That would be my guess. Let's say 26 or 27. Okay. With that in mind, which would help us, okay, if we get a ridiculous answer. So let's try to keep that in mind. And now let's try to find the answer. All right, the way we set this up is this. You have 400 miles and you can do this in 12 gallons, right? And so that proportion, we're assuming, is equal to the proportion or the ratio of 950 miles and question gallons, right? So we can, I mean, you can call this X if you want. You can call it a question mark, or you can put call it a box if you want. But anyway, you need this gallons, right? So maybe I should call this X because that's typically what you would call in an algebra class, right? This class is not algebra, but X is a sort of a nice way to indicate the unknown number. All right, 400 over 12 is equal to 950 over X. So if you are solving this with cross multiplication, right? So this times this is equal to that times that, right? So 400 times X, which you can write as 400X, is equal to 950 times 12. And 950 times 12 is 11,400. You can use your calculator to go ahead and calculate big number like that. And then you divide, remember 400 times this is equal to 11,400. So you can divide both sides by 400, or you can write this as 11,400 over 400. The point is this is 28.5 and the answer is of course in gallons. Now my original guess was like 26 to 27. So we're, pretty close. We need about 28.5 gallons of gas to get to the destination. That's one way to do this, okay? Here's another way to solve this problem. You know that you are given that you can drive 400 miles by consuming 12 gallons of gas. So if you divide 400 by 12, you get 33.3333 repeating. What is that number? Okay, if you are fuel efficiency conscious, you probably know what that number is, right? The number of miles divided by gallons. This is miles per gallon. And this represents the fuel efficiency of the vehicle. So if you know that it takes 1 gallon would allow you to drive 33 1/3 gallon, then how much gallons, then how much gas do you need for 950 miles? All you have to do is really just divide 950 by 33.333. Now, a word of warning here, you do not want to round off these numbers at very early. Okay, in fact, I would try to write as many threes as possible, 33.33333, maybe 5 decimal places, because anytime you round off, approximate, you end up giving more possible errors to the answer. Right? If you do this, you get 28.5. Okay, so that is your answer to this question. All right, any questions about this? All right, let's go to the next one. Hardwood flooring. Sounds good. Cost $800. If you want to do a 10 by 12. So this is 10 feet by 12 feet, right? So it's 120 square foot room. For that room, flooring that room by hardwood is going to cost you $800. So then how much is it for a 15 by 15 room? Good question, right? I mean, this is quite a practical question. If you have a 15 by 15, then of course you need more than the smaller room, 10 by 12. And so how much would you need? Now, this is one way to express the equality or the equation. 800 over what? You may want to, multiply these together. It's 120 square feet is equal to, let's call this x now. X over, now what's 15 by 15? It's 225. Just go ahead and use your calculator to multiply 15 by 15. So 225. And notice here, the room is about twice as much, not quite twice as much. So the answer should be almost twice as much as 800. So it's like 1600, maybe a little less. So the guesstimated answer is about 1500 or $1,500. Again, keep that in mind so that if you ever get a ridiculously big or small number, then you know that something is going wrong, right? Now you can do cross multiplication. 120 times x, that's this times that, is equal to 225 times 800, and that, do I have that number? I don't have the number, but I'll calculate that just a moment. Okay, so what you can do is cross multiply this and this, 120x, and this times this turns out to be 180,000. Sometimes, unfortunately, you have to work with a rather large number like 180,000, but then you divide this number by 120 to find that unknown number, and this turns out to be $1,500. That's exactly what we guessed at the beginning. This is approximately $1,500. So that's a way to answer this question here, right? You could also do this by some other ways. Like for instance, if you just go ahead and divide the right-hand side, the left-hand side, 800 divided by 120, what you get is a 6.66666. You can round this off to 6.6667 maybe. But what is that number? If you're dividing in dollars, okay, so this is $800 divided by 12. So this is the number of dollars per square feet. So each square feet approximately costs about 6 2/3 of a dollars, 6.67. Right. So with that in mind, that 15 by 15 was 225, right? So if it's 225, what is that? 225 square feet. You multiply this by 6.666. Eventually, you have to put 7 somewhere, okay, right? But anyway, if you do that, you will also get 1,500. You will get an approximate number because you had to approximate this last part here, but you will get about 1,500. See, or you can guess 225 times 6, what is that? But that's going to be close to like $1,400, and or you can just multiply these on your calculator and you get $1,500 as your answer. Okay, all right, let's do another problem. And maybe go into the unit conversion after that. Suppose you earn $1 per second. That would be nice, by the way. That's $60 a minute. Suppose you earn $1 per second, 24/7, around the clock, all year long. How long does it take you to become a millionaire? How about a billionaire? Okay, so this person actually has a very nice job, right? On the average, the person is making $1 per second, so $60 per minute. Now, how do you, really think about this? Well, what you can do is as follows. This person is making $1 per 1 second, right? And the idea is when you convert this to, to calculate like the number of minutes and hours and days, what you do is to multiply. Let's see how much he's making per day. So $1 per second. And the idea is to multiply these by a bunch of things that represent ones. What do I mean by 1? Okay, well, 60 seconds is 1 minute, right? So 60 seconds over 1 minute turns out to be exactly the same as 1, because the top and the bottom are the same expression, same quantity of amount of time, 60 seconds and 1 minute. And also 60 minutes is equal to 1 hour. Okay. So in other words, if you multiply 1 by 60 and 60 again, then that will tell you how many dollars this person is making per hour. But then there are 24 hours to a day. So this calculation, if you do this, will give you how much the person is making per day. It turns out that 60, and the denominator is always 1. So the denominator is 1, right? The top is going to be 60 times 60 times 24, and that comes out to be $86,400. And notice here, and this is called dimension analysis. Seconds appear here, right? And you know that when the same thing appears on the top and the bottom of a fraction, you cancel or you divide by 1, cancel each other. Minute and minute can be canceled, hour and hour. So the only thing that's left is $1 per 1 day. So this means you have $86,400 per day. That is this person's income. Yeah, that's nice. But let's say, how much time does it take this person to become a millionaire, right? So 1 million divided by 86,400, this will give you the number of days it's required for him to become a millionaire. Does it make sense? If this person can make $86,400 a day, then you divide 1 million by that, that's going to give you the number of days, right? And that turns out to be about 11.574 ... That is 11.6 days approximately. Now, by the way, this one was hard to guesstimate or estimate at the beginning, right? If you had asked me out of the blue, like how much would it take for this person to become a millionaire? I said, I have no idea. I would have to sit down and do this kind of calculation, even to come up with a reasonable estimate. But these calculations now are telling me it would take this person 11.5 days or 11.6 days to earn a million, okay, to become a millionaire. That's a definition, I guess, of a millionaire, somebody who makes $1 million. Is that okay? Yeah, so this is a highly professional, high earner. And so it would only take him less than 2 weeks to become a millionaire. The main part of this question that I want to emphasize is the difference between a millionaire and a billionaire. How long would it take for this person to become a billionaire? Okay, I mean, a millionaire and a billionaire, they both sound very rich to us, very far away from us. And, it just, what's the difference between a million and a billion? Well, it's just an M and a B. Well, okay, so let's take 1 billion, which is oh yeah, I guess I should have written this as 1,000,000. Okay, a million has 6 zeros. 1 billion has how many zeros? It's 1,000 times a million, so it's 9 zeros that follow the leading one. You divide this by $86,400 per day, and that's going to give you how many days it takes for this person to become a millionaire. Obviously, this is just going to be 1,000 times this, okay, because all I did is to multiply the numerator by 1,000. So this will be $11,576. I'm sorry, 11,574 days. Okay, and now you want to divide this by, because it's hard to tell how long this is, right? Let's divide this by 365 days per year, okay, because that's the number of days in a year, as well, unless it's a leap year. We sort of ignore leap years because it only happens once every 4 years. And if you divide this by 365, you get approximately 31.7. And that's a number of years it takes for this person to become a billionaire, right? Now you see the difference between a millionaire and a billionaire, right? Sometimes you see these athletes that go on strike, like, Major League Baseball players may go on strike or something. It has happened before. And fans get tired saying, oh, it's just a bunch of millionaires fighting billionaires. Okay. Is there any difference between rich people and richer people? Well, the answer is it would take this person, a particular person, only 11.5 days to become a millionaire, but it's going to take that person over 30 years to become a billionaire. You see the difference in magnitude between this and this? Yeah, these are very, very different numbers. And so it may be relatively easy to earn 1 million. It'll be much, much harder to become a billionaire. All right, so you can tell that the unit analysis or units play an important role when you try to calculate these things. And this is called dimension analysis or unit analysis. All right, let's do another problem here before we turn this on to the next clip. How many seconds are there in 1 year? Have you thought about this? In 1 year, how many seconds? Well, again, you can say that there are 60 seconds in a minute. That's 1, right? And then you have 60 minutes in an hour. And so 60 minutes divided by 1 hour represents the number 1, because the top and the bottom are the same. Then 24 hours in 1 day. And how many days are in a year? That's this. Okay. Now notice here the denominators are all 1. And if you do cancel the units that appear in common between the top and the bottom, the minutes cancel, the hours cancel, days cancel. The only 2 things that do not cancel are the seconds on the top and years on the bottom. If you multiply the top numbers, 60 times 60 times 24 times 365, you get 31,536,000. And so that's in seconds per year, right? So you can say there are 31.5 million. Let's go ahead and write this down. This is approximately the same as 31.5 million seconds per year. You may wonder, why do we worry about these big numbers? Well, you will see that sometimes we see bigger numbers and we want to compare those bigger numbers with the number of seconds per year, for instance, okay, just to make sense out of large numbers. So that's how you can calculate these questions, answer these questions, and use these unit analysis and cancel a bunch of units so you know exactly what comes out in the end. Like in this case, what you'll have is seconds per year, which is exactly what you're looking for. Okay, now question number 2, try to answer this question. If you're driving at 70 miles an hour, how many feet are you traveling per second? Okay, this may be an important question when you get into an accident or when you are trying to find the risk of driving fast. You can pause or you can stop this video, because in the beginning of the second part of this video, or in the second clip for this section, I'll answer this question. All right, go ahead and try this question now.